Welcome to Math Science History, where on Friday we post a short little flashcard about something mathy, sciencey, or history-y. I'm Gabrielle, and today we're talking about making mistakes and the good things that can come out of them. Sometimes, even among the best of them, mistakes are made. Through the process of moving on from that mistake, greater things can be discovered. So, today's flashcard is about mistakes, a messy scientist, and a forgotten petri dish. Alexander Fleming was born in Scotland in 1881 and grew up in a rural farming family. He wasn't from a wealthy background, but he was naturally curious and excelled in school. Fleming initially trained as a doctor and joined St. Mary's Hospital Medical School in London. During World War I, he served in the Royal Army Medical Corps, where he saw firsthand how bacterial infections killed more soldiers than bullets. This experience shaped his desire to find something that could fight infections. After the war, Fleming became a bacteriologist, studying how bacteria caused disease. He wasn't a flashy scientist. In fact, he was known for being a bit absent-minded. His lab was notoriously messy, which was a trait, as you'll soon see, that played a crucial role in his discovery. So, let's fast forward to September 1928. Fleming had been studying Staphylococcus bacteria, which can cause nasty infections. He had left petri dishes containing bacteria on a workbench in his cluttered lab while he went on vacation to Suffolk with his family. When he returned, he noticed something strange on one of the dishes. Mold had grown, likely from spores floating through the air. But here's the interesting part. The bacteria around the mold had been completely destroyed. The rest of the dish was covered in bacterial colonies, but near the mold, the bacteria had disappeared. Fleming took a closer look and identified the mold as Penicillium notatum. He quickly realized that this mold was producing a substance that could kill bacteria, so he named it penicillin. Fleming's curiosity kicked into overdrive. He tested penicillin on different types of bacteria and found that it was particularly effective against harmful ones like Staphylococcus and Streptococcus, which caused infections like pneumonia, scarlet fever, and even blood poisoning. But here's the catch. Fleming couldn't figure out how to mass-produce penicillin. The mold was difficult to grow in large amounts, and extracting pure penicillin was a nightmare. He published his findings in 1929, but at the time, the scientific community largely ignored them. Fleming continued his work, but ultimately moved on. He saw penicillin's potential, but didn't have the tools or the resources to turn it into a viable treatment. It would take another decade and a world war for penicillin to get the attention it deserved. In the early 1940s, with World War II raging, bacterial infections were killing soldiers at an alarming rate. This time, scientists in Oxford, Howard Florey, Ernst Chain, and their team picked up where Fleming left off. Using better methods, they found a way to purify and mass-produce penicillin. The impact was immediate. Infections that were once death sentences, like pneumonia, syphilis, and infected wounds, were now treatable. By D-Day in 1944, penicillin was being used on the battlefield, saving thousands of lives. It became known as the wonder drug, and its success led to the development of modern antibiotics. Fleming had originally wrote about this wonder drug, stating, quote, "One sometimes finds what one is not looking for. When I woke up just after dawn on September 28, 1928, I certainly didn't plan to revolutionize all medicine by discovering the world's first antibiotic or bacteria killer. But I suppose that is exactly what I did." Fleming, Florey, and Chain shared the 1945 Nobel Prize in Medicine for their work. Fleming, always modest, warned about the potential for antibiotic resistance, a warning that remains relevant today. Penicillin opened the door to the antibiotic revolution. Today, antibiotics save millions of lives every year. Without them, simple infections could still be deadly. But let's take a moment to appreciate the lesson here. Science isn't always about careful planning. Sometimes discoveries happen by accident, and the key is recognizing their importance. Fleming could have ignored that petri dish, thrown it away, and moved on. Instead, he saw something unusual and asked, "What if?" So, what can we take away from Alexander Fleming's story? First, Scientific breakthroughs often come from unexpected places. Second, persistence is key, even when the world doesn't immediately recognize a discovery's importance. And finally, a little messiness isn't always a bad thing. Thanks for listening to Flashcard Friday. And until next time, carpe diem.